Hello everyone. So today we are going to understand a thread pull pattern. So before understanding this pattern, let's understand what is thread. So thread is the smallest unit of execution inside a process. So let's understand a process being an application code and a thread is a worker inside the application doing a task. Why do we need a thread pool? Imagine you are running a web server and a thread is spawned to satisfy any request which is coming to your server. It processes your request, sends a response back, and terminates. Simple enough, right? Now let's imagine that your server is getting 10k plus requests simultaneously. Now, for processing this request, you need 10k plus threads. And let's assume that each thread consumes around 1 MB of stack memory. So yeah, we are just looking at 10 GB of memory for just stack threads. Store the state of the thread. This is the most common problem seen in most of the concurrent systems. So thread creation process is expensive. Context switching has an overhead, and this also leads to the wastage of memory resources and even leads to memory exhaustion because of more and more of thread creation. To overcome this problem, we have a thread pull pattern. Now let's understand what is a thread pull pattern. So a thread pull pattern solves this by reusing a fixed set of threads to execute many tasks. Instead of creating a new thread for every task, tasks are submitted to the pool where ideal workers or meaning the threads picks up them, processes them and completes the task. Let's understand how thread pull works. So let's say we have a client code which is responsible for submitting the task basically, and the tasks are held in the task queue. So whatever the client is submitting, the tasks are held at the task queue. So all of the tasks gets enqueued here, and this is a thread pool basically. So it is holding four threads, which are four. So it is having four workers, basically four threads, which will be responsible for executing this tasks which are present in the task queue. So how it works is whenever a task is pushed inside this task queue, whatever the worker which is available at that particular moment picks up the task and completes it. So what is the task queue here? So task queue is a thread set queue which is holding the task waiting for the executions, basically the tasks which are submitted by the client code. Worker threads, a fixed number of threads that process the tasks which are present in the queue. And the pool manager, which is a thread pool manager basically, it coordinates the task submission and worker's life cycle. So whenever whatever worker is available at that particular point of time, and let's say we have a task which is present in a task queue, it picks up that task and executes it. So all those worker health and everything is managed by a pool manager, which is managing the complete pool of threads. Now let's understand the execution flow of this complete process. Let's understand the execution flow for this process. So let's say we have a client which submits the task in the task queue. So task queue's responsibility is holding the tasks which are submitted by the client. Now worker thread first checks whether a task is present or not. So let's say if a task is available inside the task queue, it dequeues the task, executes the task, and checks for the next subsequent task which it needs to process. Now, let's say for that particular moment, there was no task which was submitted by the client and the task queue remained empty. So, the worker would be in the ideal state and will wait for the next task. So, whenever the next task is made available, it executes the task and finishes the process. So this is how the execution flow of the thread pull looks like. So here I've just kept one worker thread. So here it will be complete a thread pool. So just to understand it properly, I have taken it with the one example of a single worker thread. So now let's understand. So now let's deep dive into the implementation of this thread pool. So we have created a class which is a thread pool class. So it will hold the tasks queue, basically, which will hold the tasks which are submitted by the client. A worker, which are the thread pool workers, which are the threads basically in our pool. And we will also maintain a flag, which is a shutdown flag. So initially it will be set to as false. So in the constructor of the thread pool class, we'll first create and start the worker threads basically. So I have created a pool size basically. When I'll be calling it from main, I'll let you know how it is called. And here we are adding the workers to our workers list, which we are maintaining here. And we are starting the worker threads. So whenever a submit method is hit by the application client application code, which is submitting the task basically, so what it will first check is whether our we are not completely shut down. So our thread pool is active as of now. So if it is, it will add the task into the task queue. So task submits responsibilities to add the task into the task queue. And shutdown is nothing but whenever we are done with processing, we will shut down our system. So basically, we'll shut down the threads. So this all are the workers. We'll iterate through the loop and we will interrupt them. And here I've created a private class worker, which is extending the thread class. So a thread class is basically implementing an interface runnable in Java, which has a method of run. So I have overwritten that method run here. So what we are doing, we are changing this method is like, let's say if our we have not shut down, so our thread pool is currently active. So we'll try picking up the tasks which are present in the task queue. And let's say if we don't have the tasks which are present, so it will block if the queue is empty. So this call will get blocked if the queue is empty. If it is not, it will pull off the task and it will call task.run. And let's say if we were already shut down, so let's say while execution of it was shut down. I mean, all the processes were completed, all the worker threads had completed task. It will go into the catch block and it will break off from this method basically. And now let's understand this demo by seeing how it actually executes in from the main. So here we have created a thread pool of four, basically a four worker threads. So here, which means that whenever I'm initializing, so this will call this method basically the constructor with pool size is four and four worker threads will be added into a list of workers basically, which is this one. So when we hit this line, that action happens. And let's say we are submitting, assuming we are submitting five demo tasks right now. And what is this is basically I'm calling the submit method, which is the submit method is nothing but adding our tasks into the queue. So this will make sure that it uh, adds in the task queue by calling this method. So now when it is done, we will also print out the statement that this task has been completed by which thread. So that is basic this print statements that it picked up by which thread and completed by which thread to have a better view of how it is completely flowing into our process, I mean, into our code. And this is basically I'm giving some extra buffer time so that if there are some pending tasks, it gets completed before the shutting down of the pool. So this is just 5 seconds of buffer I've added here. And let's say after that, we are shutting down this pool. So basically, once we have the processes, I mean, the tasks which are submitted in the task queue, so the worker will pick up by calling. So when worker picks up the task, so it calls basically this run function and it enqueues from this queue and runs this basically the task.run process task.run method is getting called every time. And once we are done with processing, we'll basically shut it off. And now let's understand this how it's actually working. So, so when I let's compile first, let's run. So yeah. So here, task two started. So task two was picked up by thread two. Task 3 was picked up by thread 3, and the zeroth task was picked up by thread 0, and thread 1 picked up the task 1. So after that, we have the status that it completed by the individual threads which it picked off. At the end, we are shutting out the pool. So basically, the execution of all the tasks has been completed. I hope you like the content. If you like the content, do like, share, and subscribe, and drop your comments for any modifications or suggestions you want me to make in this videos. I think, yeah, that's it. And till then, bye bye. Take care. Have